Are there, but I think we start. I mean, for me to know about the crowd a little bit, I want to understand. We're asking a couple of questions. How many of you have heard the word Etherium before? And how many of you own at least one cryptocurrency? Awesome. Great crowd for me to talk, interaction. So I'm going to cover today mostly, introduction, which is usually there is. I gave this as like two different talks. I sort of mashed them into one for the first time. So let me see how it comes up. So the name of the talk is decentralization of internet. Now, okay, we know internet, but what is decentralization? I'm going to start speaking a little bit about what is decentralization, a little bit of understanding, and slowly go through and give a little bit of a glimpse about Ethereum. I mean, not really go into Web3 at the moment, but I will give you, a small teaser at the end. Maybe that's a good thing to speak for another talk. If you go and search for the term decentralization, so this is a very common diagram you will see. In fact, one of the top answered question in Stack Overflow also got it a little wrong, because usually what people say is, hey, this is like a centralized solution, and this is like a decentralized, and this is like a distributed solution. Where distributed means a single processing takes care, or a single piece of or single unit of work actually takes place in multiple nodes. That's what they say usually. But in our case, I wanted to go a little bit deeper into this and want to say what are the different particular kinds of decentralization we have. So there are multiple dimensions. If you look at architectural centralization and architectural decentralized systems, so like traditional corporations, right? So they are actually architecturally centralized. Usually, human associate themselves as some sort of hierarchy. They want to control because of Dunbar's number. They can't really go away and control. A lot of people, so they want some kind of chain of command, so that they could easily go and influence a lot of people. And architecturally decentralized systems are these are really decentralized systems. If you take on the other side, it is like politically centralized and politically decentralized. I'll give you an example of BitTorrent and traditional CDNs. If you take traditional CDNs, they are controlled by one company, but their architecture is really spread out, right? Decentralized. But if you take BitTorrent on the other hand, they are actually decentralized, politically decentralized. They are architecturally also decentralized. But there is one big difference between BitTorrent and what other blockchains you have. Blockchains are logically centralized. That means if you take a BitTorrent system, split it into two halves, they can still function as two independent systems. But a blockchain is it's like a one system. You actually cannot split them. You have to have one chain. All of them needs to say one thing at the same time, right? So that no two decisions come out. There will be always only one decisions. So this is the main thing which we have to actually think. If somebody says, hey, I'm building a decentralized system, what kind of decentralized system? Number one, it should be architecturally decentralized, of course. Number two is it should be at least politically decentralized if it's taken care by one organization or one group of people that's not good. Or one a country or something like that, that's not good. But at the same time, it should be logically centralized. That means it should be able to give one cohesive decision, right? Not like um, uh, I mean, if you take other distributed systems, right? So if you split them into two halves, you have the split brain problems, right? And they can't give you correct answers at any point of time. But in this one, it's not like that. The other one will not function. So this is what we have to look at when somebody says that, hey, what kind of decentralization do I really want to support? Why do we really need decentralization? I give you an example. So this is the real example. There is I think, some old type tribe. They are called Yap tribe in some of the Micronesian islands in olden days. What they used to do is, so this is a coin for them. So they have a lot of lime rocks around their islands. So the best thing what they did is they just actually chisel them as nice coins. And since they are big, they can't actually move them. Now this is actually something which you give to somebody and get something out from them. But this is not so small, right? So they came up with very nice idea that, hey, we will not move it physically. It's like, hey, this coin at this place in the island is owned by a person A, right? So everybody in the island knows that. They will publicize this, right? Because there were small number of people, so they would actually do that. So the thing is, they will remember, let's say they have 15 coins in the island. I think everybody in the island will remember that this coin belongs to that guy, this coin belongs. This is the very first example of distributed transaction ledger, right? So if I want to make a transaction, I go and say, hey, I'm going to get this from this guy and I'm going to give him this. So now this coin belongs to the other guy. This is possible because everybody was able to keep that in mind. Now suddenly somebody comes and says, hey, no, this coin belongs to me. And everybody will say, hey, no, I know that this doesn't belong to you. This belongs to that guy. Because the majority of people believe that it belongs to this guy, it belongs to this guy. That is what is blockchain, right? So, to say a little bit of history into blockchains. Blockchain is actually the technology behind Bitcoin, right? Not in, so they say that, to bring, like a big technology like this, right? There are a lot of small innovation over the years, and then it came into being in 2008 when Satoshi Nakamoto proposed this paper. And that is the basis of Bitcoin. Bitcoin is built on top of this, that all the nodes in the Bitcoin, they will remember all the transactions ever took place, right? So anybody who comes in tomorrow, I add a new node and then I say that, hey, no, I now suddenly own 200 Bitcoins. Everybody in the network will know that I'm lying because I actually don't own that, and they will throw me out of the network, right? So this is the basis. Now, fortunately or unfortunately, Bitcoin was built with only one application in mind, which is to transfer the cash from here to you, peer-to-peer cash. But what Ethereum did is, Ethereum came in 2004. Vitalik Buterin is the founder. He actually proposed that, so this is nice, but if we can slightly change this to have a programming language inside that, and to make it generalized enough such that I can actually code anything in there, any business logic which can be put into that. It's like a transaction, immutable business logic, and I can execute that immutable business logic at my will. So that becomes a very strong message in Ethereum. So I'll talk about that a little bit later. So, but the main thing is about the consensus. I mean, really sorry for this. This mic is really strong. Picks up everything. Okay, so yeah, I have worked on a lot of distributed systems. What is the big difference between Hadoop and other things, like there are other Paxos based other stuffs like Zab or something like that which Zookeeper uses. There are other things what Cassandra uses. What is the big difference between that and this? I mean, the big difference between this. I mean, in those systems, right? So I mean, these systems are built using the intention that, hey, I will build only fault tolerance in them, not Byzantine fault tolerance. Byzantine fault tolerance is assuming that a node will still function properly, but it will give out wrong messages intentionally uh, malicious nodes, right? So if you have a Cassandra cluster, all the machines in the cluster is yours. If you have a Hadoop cluster, all those things here. So what these guys did, they actually made the protocol very less complicated, assuming that you have a nice transport layer which will serialize things, everything nicely, and will give you. So that is the main thinking behind that, and then they actually made it very small. But if you want to put it outside that, I mean, anybody can take a code of Bitcoin code and then can actually change the protocol slightly so that they can actually do some malicious intent in that, and then can put in the Bitcoin network. That is actually possible, but that will not be possible because the protocol is designed like this. It's designed to take care of other such systems who do that. So they are Byzantine. They have special property called Byzantine fault tolerance. I mean, this is given by a simple example. I mean, I'm not going to go deep into this one. It's like saying you have five generals who want to attack. I mean, a central kingdom, and all these things. You can go and read more about this, the Byzantine generals problem. But the main issue is this, right? If you build a system which is public, you have to be Byzantine fault tolerant. That means you should actually design your system such that somebody will code something malicious and then will put it to the protocol, and then they can actually charge the network or they can bring down the network, whatever, right? Your inherent protocol should actually take care of that. One way of doing that is called proof of work, right? I mean, there are some early indications of proof of work long back, even before we had bitcoins. In olden days, when you want to send an email, like I don't know whether you can remember Alta Vista or olden emails. So if you want to actually send an email, as soon as you press the send button, your local process will do some work, right? With some calculations, or just do a sleep, or just do a while loop for 5 seconds, and then it will send a mail. Just being there for 5 seconds, if you send one single mail, is not a big problem. But if you're a spammer, that's going to impact you a lot, right? For let's say, if the guy sends 50 million emails per day, then for every email he has to do some calculations for 5 seconds and waste CPU cycles. It's going to impact him a lot, right? That is the formula here, right? So one of the way to solve the Byzantine fault tolerance problem is to say that, hey, before you give the message to the next system, or before your impact should be taken into the system, you have to do some sort of work which is provable, right? And let me give an example. Let's say that work is like finding a prime number which has 2 6 in it, for example. I'm just saying, right? So it will take some time. Let's say it takes a fixed amount of time. It takes 10 seconds. Now, for the guy who actually creates it will take 10 seconds. For the guy who actually looks at it, it will not take much time, right? So that's the same impact. To check this, it should not take much time, but to actually create that, it should take more time, right? So this is the main thing which was uh, this is the main thing which was actually used in Bitcoin. So it's called proof of work. So what it will do is uh, I I think Bitcoin it's every 10 minutes I get the block time. So at every 10 minutes what it will do is it will take all the transactions which have done in the past 10 minutes, it will put inside a block. It will actually create this thing and it should add a nonce such that the uh, hash of the block has a certain number of zeros in the front, right? So it's not an easy thing to do. You have to do it. You have to generate the hash randomly multiple times, and only then you can do this. It's not mathematically solvable. You have to do it only using brute force, right? So that's actually the proof of work. So only if you do that, and the guy who actually does that is the guy who can say that, hey, I have actually claimed this block, and then he can claim the block reward, right? So that's the way consensus is achieved there. And there are other ways also, like proof of stake and other proof of works also. I'm not going into much detail into that. I'm just going to introduce you to all these words which you can go and look afterwards, right? Because these are like one big sessions if you just took like proof of work. And I'll not be able to do justice in this time. So I'm going to just introduce you to only these things, and then you can go and browse all these things. Blockchain is, it's nothing but a chain of a group of transactions. So let's say, so this is actually the first group. Let's say this is actually the first group. Maybe Genesis block. Somebody created that and created a hash. Now, as soon as this particular thing is created, you wait for 10 minutes, and in the 10 minutes, all the transactions, you put the transactions here, and then you put some timestamp, and then you put the previous hash of this guy here, and then if you put a certain nonce, you will create a certain hash, right? And this nonce is what you have to find out. Now again, so all this Bitcoin transactions and other things are not stored as normal transaction. They are stored in a special data structure called Merkle trees, right? I mean, if you don't take anything from this talk, just at least take this. Merkle trees are the basis of a lot of things which to prove immutability in this system, right? It's like you have a file, for example, you split the file into small chunks, and then you create SHA-256 hash of this, SHA-256 hash of this, and then you create hash of hash like that. You go in the top, you will get one hash. So even if you change a small thing in any of the tree, anywhere in between, the entire tree will change. I mean the root will change, right? So usually they will store the root, and then they will use that to see whether it has actually changed or not. You don't have to store the entire transactions, right? So you store the Merkle root, and then you know that hey, it has not changed, right? And then if you have the Merkle roots, we can do proofs on that. That means you can say, hey, on the 56th row of this particular transaction, there was number 20 there. And actually to prove that, you can actually say the branch which actually contained the block, and then you can take only that, and then you can say, hey, this is the proof for me to say that this is true in the system, right? So these kind of proofs are easier to do if you actually create your data structures in Merkle, and it is and all these are immutable, by the way, right? So I want you to look at one thing. If you don't, I don't know whether we will share the slides or not. So there is one demo here. I wanted to go and look at very nice demo. So it will actually allow you to create a block hash, and then see how this goes to the next hash, how this goes to the next hash, and things like that. How much time it takes to create a hash and things like that. It's a really nice illustration of a general blockchain, right? And this is actually the basis of all the blockchain systems, whether it's Bitcoin, whether it's Ethereum, whether it's Hyperledger. So this is the basic technology. Okay, so right now, I want to come a little bit into Ethereum. I mean, I work for the Ethereum Foundation, so which is like Apache Foundation or Linux Foundation in the world. So this is the foundation which actually takes care of bringing all of these guys together and then executing this particular thing, right? Ethereum. So I mean, if you take Bitcoin, as I said, right? So Bitcoin is built on top of blockchain. It's exactly the same blockchain. I mean, not exactly. There are some changes there. But what they did is they just built one app on top of it, right? So it is like this old calculator, right? It can be used only to do that particular business, and all the time you have to throw it away. So in Bitcoin, it is used to do only a transfer of money from there to here and from here to there, right? But what Ethereum did is that Ethereum actually built a small, we call it EVM, Ethereum virtual machine, on top of this, so that you could actually build the logic in that, right? And you can actually make the logic immutable, so you can, I mean, like you can build applications like, let's say chit funds, for example, right? So these are awesome examples in this part of India. So like chit funds, they just take all your money and then vanish, right? So, so you can build, a smart contract, which is a piece of code, which will say that, hey, this if you actually put this much money, after this much time, we will give you this much dividend and all these things. And that code is actually put inside the blockchain. That means it's immutable. Immutable means nobody can stop the execution of that, of the way in that which it functions, right? So let's say that I code this and then I put in the blockchain and say, hey, I have created a new thing here. So if you want to put here, put that. So like 10 people come and put the money. I will say, hey, I will take maybe 0.01% of all these things as my fee, and I will give you a platform which is like guaranteed to give you all these things. Right? So you can come and put it there. You can see the code. You can see that, hey, after 25 blocks, everything is actually measured in block time. In each block in Ethereum is actually close to 15 seconds. So let's say I say that after 300 days I will actually give you this much. So I will say 300 days with this much blocks, and I calculate and I put in the code, and the code is there in the blockchain. Now, once I have put the code there, nobody can actually change the way it is have to behave, right? It's there, immutable. It's like immutable language which you have, but that's only for data, right? But it's actually for code. Nobody can change it afterwards. So this is a very nice, very nice use cases to build on top of this, which will give you, guaranteed executions of certain things. I'll give you some examples on the way later. But so this is not only to give you money. Give you money is one app on top of it. You could build a lot of other applications which can be like this. A lot of people are building high investment funds and all these things where usually people cheat there in US. So those things people are slowly bringing that into blockchain so that you get some sort of guarantee that you will get the money back, and you will get this much money back. And all these things. A lot of people are building other kinds of things like, okay, I want to only sell the port which comes from Europe and not from China. Let's say Walmart has actually done that. So what they can do is that at the place where they really manufacture that, they can enter that particular this thing in blockchain, and then they can track where all it goes, so that nobody can actually fudge that on the way and say that, hey, no, this ship came from Europe, so it is from Europe. But actually, somebody on the way, change it, and all these things can happen, right? So they are building applications like this where there is no need of a central party, right? If you look at that, Bitcoin is famous because we removed the bank from that, right? So we say, the famous this thing was, we don't want to bank more guys, we want to unbank everybody, right? You should be your bank. You should be in control of your money, right? If you put money in your bank, the money is actually not with you. You have a promise from the bank saying that you still have the money. You go tomorrow morning, we will give you. So that's actually the promise they give. But they break the promise. We have seen that here. We have seen in a lot of countries across Venezuela. Venezuela is actually having a bigger problem right now as we speak. Venezuela, Argentina, Zimbabwe, where the inflation is lot more than the inflation you can think. I mean, they have $1 trillion note. I mean, which is like insane, right? 45% inflation and things like that. So in this one, there is no inflation. I mean, there is inflation, but there's very less controlled inflation, right? So you can control. They see that their own this thing is not useful. So if you see that there is a producer and a consumer, and there is a central party doing some sort of exchange between them, this is a very nice use case where you can actually remove this guys. And again, I mean, if you have any questions, just ask. Don't actually wait for at the end, right? I mean, I didn't really prepare anything for that. It just comes as it is. So it might not be in a nice flow, but I'll say whatever.
No, I heard of Bitcoin things also where people lost money, right?
Yeah.
A few years back.
See, a lot of it. I mean, there are Ponzi schemes. Right? You have to acknowledge that. I'm not saying there will not be Ponzi schemes. I'm just saying that there will be only two people. One is a guy who sends, and there is another guy who receives. There won't be a central guy who will have any control of your money. Your money is your control.
There are some exchanges which a lot of people lost bitcoins in it.
Exchange is a centralized one. So exchange is again one more thing which people are trying to build in a decentralized way. That means I exchange with somebody else without a central party, right? So without actually mediating guy, right? So let's take an example. I actually came a few days back in actually a cab, Ola cab or something like that, right? So that guy said, "Sir, please don't give Ola this thing. Give me cash," right? I asked him why. He said it takes 30 days for me to give a lot of tears, a lot of problems. So then this is actually the problem of centralization, right? So because there is a guy who actually connects both of you and takes the money out from you, right? So if we can build applications where we don't need all these central guys. Actually, there is one company who are actually building that in France, in Israel. It's called Zahoor, I guess. So they are actually building something like Uber, wherein there is no central party, right? It's only the guy who wants a taxi and then the taxi guy. That's it, right? And all other governance is actually put in the smart contract. Like you have to come within this much time, and all these things are a governance issue, right? Those things are actually put in the contract. So if you don't if you don't take care of all these things, then I mean you lose some money, or you lose some deposit, you lose some reputation, you lose some.
You were talking earlier about banks being made, like taking the controls away from the banks and putting it into a decentralized mode. Okay, but isn't it so that right now many of the miners have formed a kind of a group which is controlling it, and they are like if you can carry the.
True, I understand the question. True, it's true in the case of Bitcoin. In the case of Bitcoin, all the miners are centralized in somewhere in southern China, because you have nice temperature there, and then you have free electricity because they steal from the grid, right? So what we did in Ethereum is we actually made this actually proof of ASIC resistance, right? So that means you can't really create specialized microchips which are really small, which can actually create multiple mega hashes per second. Instead of that, you have to run it in a normal computer, right? You have to run it in a normal computer. So anybody can run. Right? So if you see actually one of the these things, right, it is really scattered. It's really a lot. But again, slowly. In actually proof of work, right? We spend electricity a lot. I mean, today it's expected that Bitcoin is a lot. Even Ethereum is. They have calculated that it takes somewhere around electricity of a small country, right? So in our next release we are going to something called as proof of stake, where you don't have to do some random work in your GPU and spend CPU cycle. Instead, instead you pledge your your uh, your your money ether, right, and then say that I will behave properly in the system, right? So if I see that you don't behave properly, I will actually take away your whatever escrow you have put, right? So that
basically,
system is
there is,
coming.
if you're talking about escrow, then there has got to be a centralized.
No, there is no centralized. Everything is decentralized. If you take Ethereum, right? Ethereum, everything is based on smart contracts.
Correct.
So all these escrows, all these kinds of place where you get money, all these governance issues like, hey, I want to build an autonomous organization, for example. I want to have, a fund, crowd fund kind of thing where there is no office, there is no real people who actually do this, but instead code who does that, right? So they actually tried that. It's called the DAO if you want to look at that, but it became a real big incident after that because there was a lot of money which came into that. But slowly people are they're trying to learn. I mean, if you put too much money in one place, it's going to get hacked, right? So they are trying to do that in a very spread out fashion so that it's not one place. You may have to look at multiple places so that it will be, if you want to really go and do something which is not a good interest, you have to spend lot more money than what you're going to get, right? So that is the incentivization model which is coming, right? So they put in more, what do you call, a theory based route where you have to spend lot more money to break the system, but you want to do normal things, it should not cost you much, right? So that's the kind of system you have to put. All the protocols, they follow all these kinds of things, right? So they give game theoretic based um, I mean
Challenges.
challenges, incentivization, and all these things. So incentivization is one big differentiator here, right? If you take BitTorrent for example, right? It's a very nice system to do storage, peer-to-peer storage, and all these things. But the thing is that there is no incentivization there. So there is no. If anybody is not giving you any file or anything, there is no de-incentivization there, right? So it's up to the system to come to some level and all these things. So people have to run seeders, people have to run this thing. But if you have a nice incentivization system, and actually the good thing is that in the case of incentivization system, only the things which actually are needed in the market will survive, others will die, right? Because there won't be any incentive, nobody will do it.
Basically, like in the miners in the Bitcoin ecosystem, we have miners who are being paid for doing the validation of a transaction. Okay, are we going to be having Are we having something similar over here for the EVM? The persons who are running the EVM nodes, or how exactly does it happen?
No, it's not like that. So, even in Bitcoin, if you see, there are nodes and they are actually miners. Nodes will just validate that, hey, these are there. Miners are the guy who really mine the blocks, right? So the incentive is there for the guys who really do the mining, not for validation. But usually, what happens is that a guy who is running a mine will also run a node because we need validators in the system. But in Ethereum, what happened is that since you cannot have an ASIC based incentivized system, so you have to run it in a normal CPU or a system with actually a GPU. So it all runs in a node. So the node actually runs there in a computer which can really take and then do full node validations.
So does having a better GPU help?
Oh yeah, oh yeah, yeah. Yeah. That will be until we get proof of stake, and after that you don't really require any GPU. You are not going to mine after that. You just are going to do only validations of the block, and all the mining sort of work will be done by proof of stake algorithm, which is like a distributed consensus based.
What was the roadmap? When can we expect that proof of stake thingammy to be implemented?
Oh, okay. So we have taken a decision not to publicly anywhere tell when it will come. You can expect. So it's called Casper. Somewhere next year is what we are thinking. There is still a lot of search going on there because this is a huge step, right? This is a huge step, and there is at least $40 billion in that if anything goes wrong. So yeah, so I think we'll take some time. So yeah, so some small text as I said. So in Ethereum there are two kinds of accounts, which is one is a normal account which is you and me can have. I create an account, I will have a private key, and then I will have public distinct key which I can give to anybody. Anybody can transfer to me. If I want to take funds from my account, I have to use my private key and do that. And there is another kind of accounts called contracts, where you can send a code, and then the code will go and sit there, and to execute, it will have an API sort of it, which we call ABI, application binary interface, which is actually an executable there. So if you send a transaction to an interface, and then you can say, hey, I want to execute this particular call, it will execute it. Now, there's a big problem in that, especially if you have, real Turing complete virtual machine there. You never know when it will get finished, right? You can't mathematically prove that, an execution of anything will get completed in a given point of time. So what we have is we have a concept called gas. Gas is like the gas we spend. It's like actually the petrol we spend. Let's say I want to go from point A to point B. I know that it will take somewhere around 3 or 4 liters, so I'll put 5 liters and then I go until that time. Let's say I spend 3.5 liters, I still have 1.5 liters to pay. That's exactly what we do. When you do a transaction and you want to execute a portion of thing inside a contract, you send some amount with that. The execution amount will be actually dependent upon we have actually fixed the limit of the gas for every instruction in the EVM. So to some extent that it will take this much gas, right? Because you actually see the contract. So then what you do is when you execute a contract, you send that much of ether with that, and it will execute that one by one. And if the ether gets over, it'll just not commit the transaction, roll back the transaction, it will give it to you, that is lost. And if you have enough ether, it will go and execute it, and it will actually give back the remaining ether to you. So this is one way of stopping all DDoS kind of attacks, right? Because if you want to just execute something, it will actually cost you real money, right? You have to buy ethers, and you have to spend ethers to really do that. So that's one very nice thing. You have to look at these things. Again, as I said, so it's more general. It's not just a currency. You can actually use it to transfer any asset, right? So let's say that Indian government, tomorrow says, okay, we want to bring all the, land registration and all these things inside blockchain. Now, if I go and say that okay, this piece of lands belong to me, and if I put that inside the blockchain, nobody can change it. Nobody can change it. No land mafia, right? So these are very nice use cases of blockchain immutability thing, right? It's actually an awesome thing. Yeah, so we have an Ethereum virtual machine. It's actually a stack-based engine where you actually put things in the stack and then you actually take it out. It has actually a memory. You 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 have to spend it to store something in memory, in global memory, and things like that. So uh, it's not it's not easier. So if you actually don't write a smart contract really good, you will spend lot of money from people, right? So you have to be really concise. At the same time, you have to be really security conscious. Because if you do anything, I mean, in actually the DAO attack, what they did is that when I do a transactions, so they go there, they say, okay, I accepted your transaction, and then send back a response, and then they go and write it inside this thing. So what this guy did is he actually wrote a small code wherein he generated exception before updating the DB. So that will be called inside another callback which you can give, right? So this guy gave another callback. So that callback will have one more transaction which will generate. So like that, it will go on transaction by transaction. He took all the money out of it. So we could actually see the money going out, and then we couldn't do anything there. Yeah, we finally did. I mean, a fork, if you know, a fork, and then we took out the money, saying that forcefully not give the money to that particular guy, and then not take it back and give it to the community. So that is called a hard fork. So we did that. So Ethereum was the first to do that. I think Bitcoin is going to do now. So that is slowly becoming. Otherwise, there are some maximalists who are thinking, no, code is law. If you have written, I mean, it's like Skynet, right? If the Skynet is doing bad, yeah, you still accept it, kind of thing. But just, yeah. So these are some use cases. Real estate.
The compiler that you, so is there a high level language which a high level language you can code in and translate?
Yes, of course. So there is a language which is very widely used, or that is actually managed from long back. That's called Solidity. There is a very Python-like language called Serpent. There is another Lisp-based thing called LLM. But I think Solidity is the most advanced, using which you can write smart contracts, right? And there are a lot of the frameworks which has come, where you don't really have to do many things. There is framework called Truffle and Embark, which can actually compile and push all these things, and then it look like a very nice thing for you in the front end, right? So
Is there any standard that is being recommended by Ethereum, or is it
there is a spec. There is a spec for all the instructions that should be there inside the PVM. Because if we don't really control the spec, in some sense protect the spec, then it is very hard to define multiple clients on this. So I mean, if you actually look at this, right, Ethereum has Go client, Ethereum has C++ client, Ethereum has Python client, Ethereum has what is that language? Rust client and all these things, right? This actually says that this is a standard, not really an implementation. We do an implementation. Mostly the Go implementation is something which, which we drive. But other things like Rust is driven by parity technology, and there is like old C++ one which was done long back by the foundation, but not. We still do that, but we actually concentrate a lot on Go right now. And then we have started writing one in Python. Actually, there's one in Java also. Actually, um, very surprisingly, yeah. So
the instruction is part of the blockchain that goes along with it, or how exactly is the instruction of a smart contract implemented? How exactly
instruction is actually part of the spec. If you look at, the initial spec is yellow paper, right?
No, I'm talking about a smart contract. Okay, if suppose like we are having a code that is written for the smart contract, okay, how exactly is it propagated across the various EVMs that are there?
It will be in the chain.
Okay.
So let's say if you actually start a node right now, right? So the first thing the node will do is, okay, I have started long back. I think actually blockchain started long back. I'm starting now. That it will realize because you give actually the network ID. There are multiple networks usually. Usually there is a test net and usually a main net, and there are multiple test nets for different things. So number three is actually for mainnet. So if you put three by default, so it will actually come up, it will speak with the peers, it will understand that hey, I'm lagging behind this many blocks. So it will not do anything until it downloads all the blocks, right? If it's actually a full node, there are multiple versions of that. There is a fast sync node, which will actually not download the entire Merkle tree, but it will not download the entire Merkle tree, which has transaction and all, but will only download the header of the Merkle tree to validate all these things, right? So that will make sure that it is actually done fast. And actually, the third one is called light client, which is it will not download anything other than the account it is interested in. It's usually done for a mobile or something like that, right? Because in a mobile, I will have only my account, and I want to see only the transaction. I want to verify the transactions only for my account, and I will download only my account related things, right? So these kinds of different things are there, but this thing is the entire code. If you actually put in the blockchain, that will be part of this particular transaction, let's say. So any full node which actually downloads that can execute it, right? So it's just that it will be executed with all the nodes, right? It will be executed with all the nodes because you want to come to the same state, right? So once let's say, so now I think the block number is 300,000 something. So let's say you download all the 300,000, you will go and validate all the 300,000 yourself. You don't believe anybody in the world, right? So you actually go and execute, your node will go and execute everything. It will say, yes, it is intact. I see the nonce are exactly matching, it is 0 and this is the match, everything is fine. So it will say, yes, fine. After that, it will start listening for new transactions. So as and when the new transactions come, so when there is a blockade, I can show you one small this done by one of the wallet providers. So this is a very nice thing. Let's say you do some transactions here. So this actually goes into the chain. It comes into a pool called unmined transaction pool, and any node, any miner can actually pick up from them. So they actually take it. They put that in a nice block. Usually the miners take something, since they want more money, they pick something where there is more gas, right? So in a transaction, if there is more gas, they can actually take the gas for themselves, right? So they will take the gas. So they will take all the things, they will put it in a block, and then starts the race, right? Whoever finds out the nonce for that particular block first will just announce it to everybody, and it is very easier for others to check. They don't have to again go through 50,000 things to check. They can just check, yes, so I accept it, I accept it. It will just flow again in the floor, and then that block will be sealed and put it in the blockchain, right? So this is a nice this thing. Yeah. So use cases, there are a lot of use cases. One of the very nice use cases I see is Golem, right? So what they did is they built a smart contract based, or they are still doing as recent as last week. What they do is they built a marketplace for CPU cycles, right? So you can actually download their software, which is the blockchain. You can run it. What will happen is that, let's say if I want to execute a task which is very like CPU intensive, like a CGI rendering of an entire movie, it takes a lot of time. So people just get an entire data center for 5 weeks and then execute the entire movie there. If I want to do a task here, so I go and submit it in this one, and I have a client which says that, hey, I have some free CPU cycles, I can execute some tasks. So it splits that into small tasks. It actually sends to everybody, executes the task, get it back, and you get really paid for that, right? It's like your olden days, 1990s search for extraterrestrial. I don't know how many of you know that. There used to be a small program which you actually download the SETI thing, and then that's for free. I mean, you say that since my program is my this thing is free, I will help human race search for um, some extraterrestrial beings. And so that was the intention there. But now you do it for money, right? So a lot of these very nice things, and I want to really talk about this. This is important because I work in that way. So if you take Ethereum, right? So Ethereum, the main consensus, the main protocol, the main thing is called Ethereum protocol. So this is actually protocol, right? All three are Ethereum. And then we are working on something called a swarm, which is if you call Ethereum as the world computer, swarm is called the world hard disk. It is a internet-wide distributed storage mechanism wherein you can store anything and get paid for that. You can also build a lot of applications like based on some storage proofs and all these things that I can. Yeah, let's say if I upload my birth certificate, I could exactly say that at this string my age is this much without revealing my age. I can actually prove to somebody that my age is about 80, right? So all these kinds of nice things you can build. So this is I'm working in that team. So we are actually building it very close with Ethereum protocol. So it has a lot of this thing built into the protocol, so that it actually works like, if you think on the normal terms, think of this as like some sort of map reduced layer which takes care of the control logic, and this is some sort of distributed file, Hadoop distributed file system layer, right? So this is the actual connection between these two, right? So you can very tightly build applications which store and swarm and which can be provable in Ethereum, right? And then Whisper is actually a communication protocol which again we are building, which actually needs to bridge these two in some sense, right? We need to have some sort of communication protocols which give you really nice plausible deniabilities and all these things. When I say that, that means that I will not be in responsible for anything which is stored in my disk, because nobody can really prove it, right? Because it is split into so small chunks and it is content addressable, and everything will be linked with Merkle trees. So nobody can change it, nobody can do anything on that. You can build a lot of systems like distributed Dropbox kinds of systems, distributed systems which can actually store a lot of things and which needs to be proven, and all these things can be built using that system. I'm not going much deep into that. I'm just giving you a teaser. Maybe the next talk I can speak about that. So that is my area of expertise. I can take questions if you have anything.
What is the expected timeline for the release of Swarm and
Swarm, we are in POC 3 now. There is one called POC 4. By next year, we will have Swarm into main release. You can still download today, even today, and then can run Swarm. I run Swarm in my nodes, I run Swarm in Python and all these things. So you can still download it, but you can't store something and then expect it to be there because it might just go off.
So Swarm, when it is operational, will it be kind of a escrow kind of thing that can be envisaged?
See, we are not building some sort of application. We are just building something like what Ethereum did, right? We are building a set of protocols which can be used to store stuff, which can be used to prove stuff and all these things, and you can write a lot of applications on top of it. It's very easy. We are exposing HTTP interface and all these things. So it's like BitTorrent in some sense. You split it into chunks and all these things, but we have a much stronger routing layer underneath. We have much stronger guarantees. I know people who write live strings on top of it. so that I can stream from anywhere to anybody, which is provable in blockchain. Right, that's important. Right? Let's say if I capture, hey, this guy is giving some money to somebody, I can actually prove in code that it really happened. Right? Yes.
You said about hard fork.
Yeah.
Someone cheated the system and Ethereum hard forked and took back the secret. Right?
No.
Then,
Someone cheated the system,
yeah.
and community voted to do a hard fork and give back their money. Yes.
That's it.
It's not centralized. It's not centralized. There was one there was one false news that Vitalik was dead and all these things. So what he did is he took a selfie of the current block hash and then he sent that. So I mean, it's not. He's not centralized.
When you explained, you didn't explain that community voted.
Yeah,
So
community
the
voted.
Ethereum Foundation.
See, okay, let's say Ethereum Foundation made this thing available. It is the miners who chose to go to this fork, right? So 85% of the guys chose to go to this one, saying that, hey, we as miners, we want the money to be given back to the guys to whom it belongs. Ethereum Foundation didn't force anybody to move to this fork. You still have some people in that fork, ETC. If you would have forced, they would not be ETC now. Yeah, good, thanks. Yeah, I'll be here around. You can. Thanks for the